Hello, my name is Jonathan Schabowski and I'm a senior architect in the office of the CTO at Solace. And I'm excited to speak with you today on the topic of microservices and give an overview of their definition, characteristics, and how ultimately they can provide real business value. In addition, I'll speak to how and why they're evolving towards event-driven and talk specifically around smart endpoints and dumb pipes and how they fit within the event-driven paradigm. So let's start off with some definitions. I've chosen my two favorites, the first being from Chris Richardson and the second being from Martin Fowler. So if we take Chris Richardson's and we decompose his paragraph, first we'll realize that first and foremost, it's an architectural style that promotes loose coupling, and that it's this loose coupling that enables continuous delivery and technology evolution. Another way of stating this is that it also provides agility. Subtly, it also mentions that it's perfect for large and complex applications. So let's break that down. In my opinion, microservices aren't a panacea, but provide benefits to medium and large applications and enterprises. If you're writing a small, non-business critical application, then there's absolutely nothing wrong with writing it as a monolith. In fact, it could be quicker. But for the domains and problems that I've worked on, which tend to be of the large size, microservices have really proven their worth. So if we move on to Martin Fowler's definition, he provides a list of characteristics such as componentization, which really implies loose coupling, also being focused around business capabilities, not technology, smart endpoints and dumb pipes, which we'll actually talk about in depth shortly, decentralizing data storage and persistence, and continuous delivery. So I think both of these definitions have a few unique things, but ultimately they have a lot of commonality. And so ultimately your takeaway should be that it's an architecture comprised of loosely coupled services, organized around business capabilities, not technology, that it enables CI/CD and the capability to evolve with technology. So now that we have that foundation set, let's take those characteristics and relate them to business value. Because while it may be interesting from a technology perspective, we ultimately have to align with business objectives to be successful. So here's that list of characteristics again, the first being loosely coupled. Well, we know what this means from a technical perspective. The business vision, however, is that change can occur, we can be in sync with business changes without major ripple effects, and that the new services can be plugged in with reduced system impact. Essentially, this was sort of possible with simple monolithic code bases, but you really run into a big problem where you have a large application that actually spans multiple development teams, and these development teams are all developing with different schedules and milestones. Essentially, if you're deeply coupled, like in the case of a monolith, then you and your team's milestones could absolutely be ruined because other teams either aren't aligned with your objectives and schedule, or they're just getting off of their own schedules. But if you're loosely coupled, then you're in fact reducing that external dependency. You're able to deploy independently and have better agility. So the next one, being organized around business capability, this is actually really important. Historically, we aligned organizations by technology stacks. You had the service developers, UI developers, database guys, middleware folks, etc. Each person, if you think about it, was really an expert in the technology, but pretty agnostic to what the overall business capability was that was being implemented. This has now been sort of flipped over such that organizationally, teams are focused on a business capability and use technology components to implement the capability. Thus, they're kind of what we call full stack developers. Maybe they're not experts in each of these technologies, but ultimately industry has found that it's much faster to build applications in this way versus by technology stack. So microservices really allow you to decompose the business capabilities such that the teams are focused on delivering the capability versus the technology component. So if you think about it, as an example, how does it really help the business if the database team delivers on time, but the web UI team isn't? Therefore, there is no real business capability to what's been delivered. So moving on to the next, business logic in the apps and not infra. This is really smart endpoints and dumb pipes, and it's a reaction to having business logic in the infrastructure and the inability to troubleshoot and the specialization involved in creating the logic itself. So back in the day, I was actually always on the ESB team. I was one of those guys, if you will, developing mediations and data transformations and orchestrating services, etc. Really, the problem is that, number one, I had to be trained on each of the different ESB platforms and thus become very specialized just in those platforms themselves. And two, I would say when there was a problem, we always, of course, blame the app teams or the service teams, and the app or service teams really blamed us. Ultimately, at the end, everybody had to be involved to troubleshoot and solve the problem. So what we really have learned is this isn't a good idea. Why not have the business logic contained in the application or in a service where it belongs and use generic development tools and languages that are widely known and have the infrastructure do things like support connectivity and data routing? Thus, the concept of smart endpoints and dumb pipes. Again, we'll talk more about this because this really actually seems to have a lot of people confused by really what the intent of this is and ultimately how you implement with smart endpoints and dumb pipes. So moving on, decentralized data management. So it's really nearly impossible to have a canonical data model across the enterprise that is both A, everything to everyone, and B, agile to change. In addition, while using centralized or unified database is nice, in that it's really the one-stop shop for data and state, it's kind of like a boat anchor if you think about it that each team drags along. Because each team has to synchronize their schemas, usage patterns across the different teams, thus coupling the teams together because of the technology versus the business capability. Which, if you think about it, it's really a violation of being aligned by a business capability and not by a technology. So really, nobody in a perfect world wants to decentralize their data because of side effects like dealing with eventual consistency. But it turns out that this is needed in order to be organized by a business capability, as we discussed, and for the agility to really have polyglot databases that are specialized to the use case in the business capability versus one database that really isn't all that specialized and ultimately every team has to do a lot of manipulation and massaging. So the next one, continuous delivery and deployment. This is so standard today, I'm not really going to spend a whole lot of time going through this, but again, it's about agility and efficiency and consistency. Business-wise, it's about time to market for both greenfield capabilities and updates to existing applications. And last, but certainly not least, to support technology evolution. I mean, nothing in our lives is static, especially when it comes to technology. When you build a monolithic application with a monolithic code base, it's really, really hard to take individual components of the monolith and tech refresh them. Instead, you really have to end up big bang, using a big bang sort of methodology and lift and shift, which is A, risky, B, expensive, and C, by the time you're done, you're probably already behind the 8 ball of evolution. The loosely coupled services within a microservices paradigm can be modified to take advantages of innovations independently of other services and where it makes sense. Not everything needs to be updated, and we of course know that. But what we're trying to avoid is the pain we see daily of organizations trying to migrate legacy applications such as mainframes and other types of legacy monolithic applications, trying to port them into cloud native. And ultimately, what we know is we can't keep doing the same thing over and over again. So microservices really can help out with being able to independently change services to take advantage of technology evolution. So far, we've really talked about microservices generically, kind of regardless of the style in which they interact. But what we're seeing is that there continues to be a shift in industry towards event-driven as it applies all the way from the business down to the interactions between the microservices. Gartner has been mentioning this for some time, and large and successful companies have actually been using this as their foundation for a while. The key is that event-driven really does maximize agility as it liberates the data from being at rest, maybe in a database behind an API, to being at motion, consumable in real time as events happen throughout the business. That in of itself is actually a really big deal. But there's a lot of confusion as to how this is to actually be implemented. So if we go back to the smart endpoints and dumb pipes, it turns out that this can actually be interpreted in a number of different ways. And I've seen this in the field. Some developers believe that APIs are exclusively the medium for interactions between microservices, and that messaging and event-driven is really just an old school relic of the past. In my readings of different microservices experts, I can see where they would get this viewpoint, and it actually comes down to the definition of messaging middleware. During the SOA hype days, messaging middleware became a big bloated mess of different components, including enterprise service buses. As we discussed before, mediation logic in the network is really not a great idea. So if we're talking about that, then I fully agree. It really should be avoided within the microservices world. But I would also claim that routing messages is not a smart pipe. In fact, API gateways do this today, and that's not a contradiction. So my advice is be careful about performing mediation in content-based routing, message enrichment, service orchestration, message transformation in the infrastructure. In fact, Mark Richards, who says, quote, "The microservices pattern does not support the concept of messaging middleware," goes on to say REST in simple messaging, which is what event-driven really relies upon, is fine. So to conclude, here are my takeaways for this segment. First, microservices architecture has value, but really analyze your application and its needs before you jump in. Again, it's not a panacea, but provides value for large to medium-sized applications. Two, event-driven maximizes agility. So in some coming videos, we'll show you why that is exactly, but for now, ponder the two interaction paradigms, both API-driven and event-driven, and consider the power of liberating your data and putting it into motion. Three, microservices means you're building a distributed application. That comes with some side effects that you didn't have to previously worry about with a monolithic application. So if you understand those laws, you'll be successful. And if you ignore them, you'll probably end up in big trouble. And finally, smart endpoints and dumb pipes. It doesn't mean you can't use an event broker. Routing is not smart. In fact, every IP router and switch does that today, which is the backbone of TCP/IP and ultimately HTTP and APIs. The key is that event-driven and the use of an event broker enables your application to react in real time and be much more resource efficient as compared to an API-exclusive approach. So this video is just segment 1. So look forward to the next episode where we'll talk and discuss about the RESTful request-response paradox, and we'll dive into the pitfalls of an API-exclusive microservices approach, and while ultimately RESTful APIs are simply not enough. So thanks again for watching this video. Feel free to interact with us on Twitter, through our website at solace.com. Thanks a lot.